Let us do an experiment to investigate whether salt crystals are really dry or not. This experiment procedure, or process, is also called hydrated and anhydrated process. The apparatus required for this experiment are boiling tube, burner, and test tube holder. The chemicals required is copper sulfate crystals, CuSO 4.5H2O. Let's start the procedure. Take some copper sulfate crystals in a dry boiling tube. We observe that initially, the copper sulfate crystals are in blue color. Heat the crystals strongly by keeping the boiling tube over the flame of a burner for some time. On heating, the blue copper sulfate crystals turn white and a powdery substance is formed. We observe tiny droplets of water in the boiling tube. Please note that an anhydrated copper sulfate is formed, white substance. After cooling the boiling tube, add 2 or 3 drops of water on the white copper sulfate. Blue color of copper sulfate crystals is restored. We observe white copper sulfate becomes blue again and form as crystals. The conclusions for this experiment are: water of crystallization is a part of crystal structure of a salt. Water of crystallization is not free water, it does not wet the salt. Thus, the salt containing water of crystallization appears to be perfectly dry. Now let us learn about plaster of Paris. Calcium sulfate hemihydrate, or calcium sulfate half hydrate, is called plaster of Paris. Formula for plaster of Paris is CaSO 4 Plaster of Paris used in construction industry. Now it is used for supporting fractured bones in the right position. Let's see the preparation of plaster of Paris. Plaster of Paris is prepared by using gypsum, calcium sulfate, that is, CaSO 4 On heating gypsum, that is, calcium sulfate, at 373 Kelvin, gypsum loses 3/4 of its water molecule, and becomes calcium sulfate hemihydrate, CaSO 4 The chemical equation is CaSO 4 on heated at 100 degrees Celsius, it gives CaSO 4 plus 1½ H2O. Gypsum on heating to 100 degrees Celsius gives plaster of Paris plus water. Please note that if gypsum is heated above 100 degrees Celsius, then all water of crystallization is eliminated, and forms anhydrous calcium sulfate called dead burnt plaster. Dead burnt plaster does not set like plaster of Paris after adding water. In formula of plaster of Paris, we have shown only half molecule as the water of crystallization. It is not possible to have half a molecule of water. Then, the formula of CaSO 4 actually means that 2 molecules of CaSO 4 shares 1 molecule of water of crystallization. It can be written as 2 CaSO 4 The chemical equation is gypsum on heating at 100 degrees Celsius gives plaster of Paris plus water. Please note that we write plaster of Paris as CaSO 4 or as 2 CaSO 4 Both are same. Let's see the properties of plaster of Paris. Plaster of Paris is white powder. Plaster of Paris has a very remarkable property of setting into a hard mass on wetting with water. It is due to its hydration, to form crystals of gypsum. Plaster of Paris should be stored in a moisture-proof container. In the presence of moisture, can cause slow setting of plaster of Paris, due to its hydration. The uses of plaster of Paris are: plaster of Paris is used in hospitals for setting fractured bones in the right position. Plaster of Paris is used as a fireproofing material. Plaster of Paris is used for making surfaces smooth before painting them. Plaster of Paris is used in making toys, decorative materials, Blackboard chalks and casts for statues. Plaster of Paris is used in chemistry laboratory for sealing air gaps in apparatus, where airtight arrangement is required.